On today's episode, understand these 3 simple concepts and you'll understand fusion power. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. On December 5th, the team at the Lawrence Livermore National Laboratory's National Ignition Facility achieved a historic breakthrough in nuclear fusion research. They used 192 high-powered lasers to compress a tiny fuel pellet to induce nuclear fusion, a reaction that resulted in 3.15 megajoules of energy output. Now, the energy applied to the pellet was 2.15 megajoules, meaning the experiment achieved a key milestone in fusion energy development: net energy output. That's a big deal for the physics community, and the mass media have been reporting this breakthrough as a significant step towards commercial power production using fusion. Well, that's a mistake, and here's why. For nuclear fusion to become a common power generation technology, 3 critical criteria must be met. The first is called scientific break-even. Now, that's what the Lawrence Livermore team has achieved, yielding more energy from the reaction than the laser energy applied to the target. From an engineering perspective, however, the total amount of energy consumed by the entire reactor system is considerably higher. Typical efficiencies in solid-state lasers are in the range of 60 to 70%, although experimental results have been published at 80% efficiency. Added to this energy input for the lasers is energy that must be consumed in things like vacuum pumping, gas handling, and cooling for the high-power equipment. If, or more probably when, one of the fusion technologies produces more power than the total power applied to the entire reactor system, it will have achieved engineering break-even, which is the second major criterion. Now, engineering break-even means true system output power, although even this won't be enough to create commercial power reactors. The third and critical stage is commercial break-even, the point at which the cost per watt emerging from the generation system is cost competitive with the cost per watt delivered by other technologies. Now, most fusion systems generate heat, which is converted into electricity the same way as every other thermal generation source, so conversion efficiencies from heat to electricity will be the same. This means that the fusion reactor has to be cost competitive with other heat sources like combustion, fission, and geothermal. Direct energy generation using technologies like solar panels or wind turbines, well, they're already very cost effective in many locations, especially with grid-scale battery storage to take care of the intermittency problem. Photovoltaics in particular are coming on strong. And as cell prices drop and efficiency increases in lockstep with improvements in battery technology, even a workable fusion reactor may struggle for a foothold in the commercial power generation space. Now, even then, I think it has a bright future in the unexplored uses for a clean source of heat. Hydrogen production with non-electrolytic dissociation of water may be a possibility, and process heat for industry, a major user of energy, well, it makes sense for this technology. And it could also be useful for space heat, and in the far future, as a form of high-efficiency spacecraft propulsion that could make interplanetary travel practical with much higher speeds. Now, this is all great, but the achievement of scientific break-even at the National Ignition Facility achieves only the first step, scientific break-even. It's going to take engineering break-even and then commercial break-even before any fusion technology produces 1 watt of power out of your wall outlet. But it's a start. Well, that's it for today's episode of End of the Line, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.